15, we're given a triangle with side lengths of 10, 11, and 14, and trying to figure out if that's going to be a right triangle, or an acute triangle, or an obtuse triangle. We've seen that if it's a right triangle, then the Pythagorean theorem would work, and looking at these values, 14 as the longest side would be my hypotenuse. So if it's a right triangle, 10 squared plus 11 squared would really equal 14 squared. But if it doesn't, we're able to tell if it's acute or right based on which side of the equation is larger. So I'm going to set this up, and I'll first start by just writing a squared plus b squared equals c squared again. If it's balanced, if a squared plus b squared is the same as c squared, we said that would be right. But if this side of the equation is larger, it's going to be an acute triangle. If this side of the equation, the c squared by itself, is larger, then it'll be an obtuse triangle. Okay, so let's see what we get when we plug in those values. We'll plug in 10 squared for a squared, 11 squared there, and c squared would be 14. Okay, and again, I'm writing equals, but I don't really know that for sure. This ends up being 100. 11 squared is 121. And 14 squared ends up being 196. Okay, so when I add these together, I get 221, and that's compared to 196. I'm not going to write the equal sign down because I know now that that's not true. This side, the 221, is larger. That's the a squared and the b squared together. Therefore, this triangle must be acute. If we would have seen that this side was the larger side, then it would be obtuse, or if it would have been equal, then it would have been right. But in this case, a squared and b squared means it's an acute triangle.